This is Neil Schneider for MTBS-TV at SIGGRAPH 2019. I'm in Intel's suite just after their big announcement series here at SIGGRAPH. To my immediate right is Jules Urbach. He's CEO of Otoy. Welcome to the program, Jules.
Thank you so much. It's a pleasure.
So for those unfamiliar, what does Otoy do?
We're a graphics software company. We make the very popular GPU render Octane. We're also well known for Lightstage, which is the industry standard for digital doubles. If you've seen the Avengers or Star Wars movies, when you see a 3D head, it's scanned in with our Lightstage service. So we touch all parts of the CG and graphics pipeline, and we're also a big proponent of GPU rendering, cloud rendering, and AI rendering, and holographic rendering.
Well, good stuff. Now, what caught my eye, the reason why I said, you know what, I need to talk to Jules, is because you were presenting today about a modern-day holodeck, but not just a modern-day holodeck, a holodeck that could actually work. Can you elaborate a little more?
So the holodeck itself is a concept that was introduced and popularized by Star Trek in the 80s. And when you think about all the passion that people have around VR and AR, what they really would love to have is those experiences without wearing any glasses. I mean, we've seen the trend in the industry where if you don't happen to wear a pair of glasses to have a 3D experience, that's better. So imagine that very same experience translated to holographic walls and tables and the like. And that is possible because you have very small display panels now that can have 4,000 DPI and spray out all the rays you need, 1 trillion rays roughly, to give you a square foot of holographic motion, and that is what you would need to power the holodeck. We're partnered with a company called Lightfield Lab. They're building these display panels up in Santa Clara, and we've seen them, and Raja has seen them as well, and they actually do project out and in a holographic surface, and it looks completely real. You can put ground glass through it, magnifying glass, you have full convergence. There's nothing like it. If you've seen autostereoscopic displays or parallax barriers, there's no comparison. This is something else altogether.
So you get true stereoscopic output, but it's more than stereoscopic because it's multi-view, yeah?
Yeah, it's like looking out of a window. When you look out of a window, you don't worry about whether there's a parallax or lenticular ghosting. It just looks perfect. This has the exact same properties, and in fact, it would probably be used at some point to replace windows. If you want to have a Park Avenue view from any room in the world, you can get that. If you want a window to Mars, it'll look like you're looking at the Martian landscape, and your eyes will focus on that perfectly. You don't need to track anything. It just looks real, and it's a lot of computation power, but it's totally doable.
Now, one of the considerations with displays like this, anything to do with stereoscopic, and I know this is beyond that, but anything to do with stereoscopic requires a trade-off in pixels, right? You lose some resolution because it has to be reserved for the left and right eye. In this case, I imagine there's much more going on.
DPI, I mean, if retina resolution is looking at your phone at this close range and it's 400 DPI, imagine having 100 subpixels for every one of those retina resolution things that can spray out rays in all directions. That's what that display has, and I've seen it with my own eyes. It is hyper resolution. It looks so crazy because you move your head just slightly. Both eyes see the image perfectly tracked, and you can focus on different depths, and that's something I've never seen in any other display before.
Now that sounds really amazing. So how big is this display that you've seen?
The current one is 6 by 4 inches, and Lightfield Lab by appointment will actually give you a demo of it, and press and developers like myself have seen it, and Raja being one of them as well. It's amazing, and you can actually stitch the panels together. So they have 2 of them. You can actually put them next to each other, and you can have a larger and larger holographic surface. So they're going to be shipping 2 foot by 2 foot panels, and you can stitch those together like the Samsung video walls that they showed at CES into any configuration you want. So you'll be paying for holographic displays by the square foot, and if you have millions and millions of dollars, you can configure them into a holodeck in the next 5 years. It'll just cost a lot of money, but
let someone else buy it. They can send me a media kit.
Yeah, exactly.
Well, that sounds really exciting stuff. So why is Otoy personally excited about this technology?
I mean, I started the company to really figure out the challenges around holographic capture, rendering, delivery, and so for me the last step was I need a partner that could build these display panels. We have that with Lightfield Lab. We're actually part of a standards group called IDEA that's building open standards around that. And we need partners like Intel to build the hardware at this kind of scale that would power every square foot of these panels. And it's a combination of ray tracing hardware, GPU cores, AI, ASICs as well that can, the equivalent of tensor cores that can help denoise those renders. Those 3 in combination at scale is what it will take to power the holodeck this decade.
I mean, it sounds to me like we're talking exponentially more horsepower required to drive technologies like this. I mean, mean, we're saying, oh, 4K, 8K, 16K, but this sounds like this is going
more is what's required. So that's why we need advances like ray tracing ASICs that can actually boost rendering speed or ray tracing speed about 10x per watt. AI denoising also is something that can solve the rendering equation probably about 100 times faster than just waiting for the rays to sort of be denoised. So those things already are giving us many advances just this year, and that's the minimum that we need to be able to to start powering these displays. Like right now, it takes 2 super high-end quadro cards to power one of these display panels. So we need something different than that. Just that's basically already just 1/6 of a square foot. So you can imagine you need 12 of those to power 1 square foot of holographic display panels. You need truly a revolution in these things, and you need investments in ray tracing ASICs and a whole other way of thinking and stacking compute cores together to make this thing work. So we're looking for partners that are going to be building that, and Intel and Raja are up for that. I mean, Raj and I have been talking about the Holodeck for 12 years. We've known each other for a very long time, so it's kind of awesome to be at the point now where we can really start to tackle the problem meaningfully.
So now they've got the visuals down pat. It's just a work in progress of time and processing. Exactly. And next they got to figure out a way to slap you around when you're in this Holodeck with Klingons and so on.
Yeah. So there is actually touch. It's being added to the second generation of these panels using ultrasonics. You'll be able to touch the surfaces and actually interact with it that way. And then third generation is going to have the holographic displays will be reversible, so you'll be able to capture holographically on the same surface that you can project, and that way you can have like a 2-way mirror for teleconferencing and telepresence. That will be revolutionary, because then you and I will be able to look at each other, across the world as if we're really standing there. No glasses, no nothing. That will change everything. So telepresence for me is that.
That sounds really exciting. Well, thanks so much for joining us.
My pleasure. Anytime.
This is Neil Schneider for MTBS-TV at SIGGRAPH 2019. We will, of course, be back with more. Thank you for watching.